A moving clock that ticks with numbers and decorations and a pin in the middle that is simple to code with less than 100 lines. Let's get into it. First, import turtle. And I'm also going to use polar angles, polar system. So that means I'm going to import math, because I need to use pi and I used to use trigonometry. Oh yeah, I'm going to use datetime as well to have for the clock to be synchronized with something, using datetime.strftime and everything. And we are also going to use winsound so that the clock so that the ticking sound can play. Now we are going to use object-oriented programming class hand. This is our object, and define initialize self.width float size float handType string. So this will be the width of the clock hand, the length of the clock hand, and that will be the type of the clock hand. If it's whether it be second, minute, or hour. Self.width equals width, and here any variables that have a self dot prefix in it can be used. They can be used in the within the entire class. Even if I just start a new definition and then do this, I can still use this variable and it would still be valid. So self.size and actually I'm going to use camcat here and self.turtle. So here I'm going to do the configuration inside the class. Shape equals shape equals square, and this is just a fancy way to just reduce a line of code and make it much simpler. Self.turtle.speed 0, so that it doesn't take forever to animate. If handType is equal to second, so if the hand is a second hand, self.turtle.color red, so that it can be clearly seen that it's a second hand but not just a minute hand. Self.turtle.shapesize stretch width equals self.width divided by 10, which means that the thickness of the clock will be that this amount of pixels. It's actually twice the amount of pixels of this, because the the side length of the square is 20 pixels. So width equals equals two times the number of pixels, because 20 divided by 10 is 2. So that will define the width, and then stretch length equals self.size, and the length of that will be 20 times the given size. So this will be the conditions if the handType is a second. Now if it is a minute, it's basically just copy this and then elif handType hour, copy, but we are going to divide self.size by 2, so that it will be half as long as the other hands. And then, and if it's not, and if the user has inputted neither of them, for example, if they didn't input second, minute, or hour, or they just put a different capitalization of second, then we're just going to raise an error. Otherwise, it will just be a useless clock, and it will not be clear. Raise key error, check capitalization and spelling, and make sure it matches second, minute, hour. Check. Just go to. I'm just going to replace it here, and I'm just going to do this and do that, and there we go. And then we have finished defining, created the clock hands. So let's say second equals hand second 5:15 second. So let's see what we have created so far. And there we go. We have a second hand. Let's change that to minute. And there's our minute hand. And then let's finally see if hour works. And there we go. We have an hour hand. And let's just put something. And there we go. We get the error. Ignore all of this, but here, raise key error, check capitalization, make sure it matches second, minute, hour. There we go. So that means that the error has triggered, and so now we have the hour hand here, and so second, and then we're also going to create two hands, minute, and then hour. There we go. Second, minute, hour. There we go. We have the three hands. And then and now we are going to make these hands move. Find update self.now equals datetime.datetime.strftime string time string of the time datetime.datetime.now. And then the format will be H set set S. There we go. Self.hour int self.now 0 2, and then self.minute. So basically the first and second one equal self.now 3 to 5. So basically the first one is index 0, index 1, and then it doesn't reach it doesn't count index 2. So this one's inclusive, but this one's not. So actually this second it's self.now 3 to 6 to 8. So the 6th and the 7th. So 2 digits, and then a colon, 5 digit, 2 digits, and then a colon, and then and then and then this one's the 7th digit, and then the 8th character, the 7th and the 8th character. In human speak, not in computer speak, because that's actually 0th, 1th, 0th, 1st, 2nd. It begins from 0. So in computer speak, that's what it begins. So if self.hand self.handType, notice here, I'm just going to change these to self. Notice that we have used a variable that we have defined in the initialize, and it will still it can be used here as I explained. Self.headed equals self.second times minus 6 because because the second will create a the second hand will create a full revolution, which means that it will spin 360 degrees in 1 minute. And so 1 minute equals, and so every full revolution, just 1 second, it will just create 1/60th of a revolution. So 360 divided by 60 equals 6. And the minus sign is so that it spins clockwise, so that when self.second increases by 1, it will just decrease the heading, because every time the heading is increased, it turns anti-clockwise as it gets increased. But if it just gets decreased, it will turn clockwise as it gets decreased. So so that so we are going to use minus signs here. Elif self.handType is equal to minutes self.headed because self.minute times minus 6 because 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 the minute just creates a full revolution every hour, and so 1 hour is 60 minutes. So and well and so every minute the minute hand will turn 6 degrees, and also and also every minute the hour hand the every minute the minute hand turns 6 degrees. So every second the minute hand must turn 1/60th of 6 degrees. Second times 1 is 6. So 6 divided by 60 equals 1/10. So we are going to do divide by 10, and we are also going to make it negative so that it spins clockwise. Otherwise, it will just go against the clock direction. Type is equal to hour self.headed equals to self.hour times minus times uh, minus 30, because the hour hand completes a full revolution every half day, and in every half day there's 12 hours, and so each hour the hour hand will turn 30 degrees, because 360 divided by 12 equals 30. And I've explained the minus sign bit so that it turns clockwise. And then also it's not a times here, it's actually a plus self.set minutes divided by 2, because every hour the hour hand turns 30 degrees, and every minute the minute hand turns every minute the hour hand turns 1/60th of 30 degrees, and 1/60th of 30 is 1/2. So it will turn half a degree. And also self.second divided by minus 120, because every minute the hour hand turns half a degree. So every second the hour hand will turn 1/60th of half a degree, because every minute has 60 seconds. So so 1/60th of a half is 1/120th. And also, so that it spins clockwise, we have minus signs. And also, we also need self.headed plus equals 90, or else the hour or else the hands at 12 o'clock it will just face east when it should be facing north. So that we spin the hour hands anti-clockwise every by 90 degrees, so that it faces north instead of east. And then self.x equals self.size times 10 times math.cosine. So this is the equation to define the coordinate point on a circle. This is called the polar angle system, and I'm not going to explain that. If you don't understand the polar angle system, you can review that and search it up, because I don't need to bore my audience to death by explaining something by explaining something which is really hard to explain, and it probably will take very long because it's because it's got to do with a bit of triangles, and I'm not going to explain it. It's also got Pythagorean theorem a bit, but turtle up back to code self.turtle go to self.x self.y. So basically, what we are doing here is to define the heading, and we are also going to define where the bit in the circle is, and then self.turtle.set heading self.heading self.turtle.down, and that's our configuration. That's our update done. Now we have completed the class. And we are now going to now I've triggered an error here. Yep, invalid syntax. And here we have finished creating the hands. And we are going to create clock hands list to contain all of these: second, minute, hour. Actually, hour, minute, second. It shouldn't. The order shouldn't really matter, but hey. Clock face equals turtle.turtle. Shape equals circle. Clock face dot speed 0, so that it doesn't. So that clock face is basically created the actual clock and the decorations of it, and we're trying to speed it up to as fast as possible. So it'll just take forever to configure. Clock face dot hide turtle, because I don't want to. Actually, I'm not going to hide turtle. Clock face dot up. Clock face dot go to 0 360. Clock face dot down. Clock face dot width, and so that it draws a nice bold border of a clock. Clock face dot circle called minus 360, so that it goes around the clock and not just in a different direction, so that the circle is not flipped over as it just begins turning anti-clockwise instead of turning clockwise. There we go. If I put 360, it'll just go this way. It'll just go here and off the screen. So I've done minus 360, so it ensures that it goes around. And then clock face dot up, clock face dot set y, clock face dot y core plus 70. In other words, we actually, nope, it's not plus 70, it's minus 95. In other words, we're just setting is to 265. So that's what we're doing. Clock face dot end. No, not end. For our year range, so 12. Clock face dot circle minus 295 and 30, so that it just goes around about 30 steps increments. Clock face dot right 90. Clock face dot right string I plus 1 font equals Arial. You could change it to Times New Roman if you want. 30. Normal. You could change it to bold if you want. Maybe even italics. Align equals center. Oh, yeah, that good. There we go. And now clock face dot left 90. And then there we go. Actually, we probably don't need any of this. Don't need it. There we go. We didn't need the pointless turn left, turn right because it added no value except just made the code slower. So we didn't need it. Clock face dot set y, clock face dot y core plus 70. In other words, set the coordinate to 345. And I also obtained these values from trial and error. So don't ask me where I got that from. For I arrange 60 so that we are going to draw 60 marks on the clock to indicate the second or minute it is. If I% 5 is equal to 4, I failed to do this. So this means that every four black stamps will equal to a fifth red stamp. So and also the circle will be 1.8 times bigger. Clock face dot color red. Clock face dot shape size 1.8. I also made a mistake here. Otherwise, clock face dot color black. Clock face dot shape size 1. And then clock face dot circle minus 335 6. Clock face dot stamp. Yes. And yes, I made a typo. And there we go. We have finished the decorations now. All it needs now is a pin in the middle. So we just go to clock face dot go to 0 clock go to 0 clock face dot shape size 2. And so it's red in the middle, but the original fit is actually black, but clock face dot color black. So that it appears black in the middle and not just red. And there we go. We have a pin in the middle of a clock. And now we are ready to make the actual clock hand spin, which is a fun bit. While true or clock hands. So we now go to make sure that these activate. So we've defined how to do it. Now we're going to activate it. Clock the updates, and then try. What else? We'll just b equals int datetime dot actually. Nope, that didn't work. It's just basically the same thing. So I'm going to copy this. So it's basically how we are going to do this. We have defined this before, and there's a second bit. The second bit is the bit where it talks about the current second. This is a bit that we want. If b is not equal to a, either either B is 1 bigger than A, or B, or B is 00 while A is 59. Winsound dot play sound. So at this point we want to make a ticking sound. Winsound dot play sound, tick dot wave, and here I make a ticking sound. I've saved a file called tick.wave in the same folder as this file code was been created. And to create the tick.wave sound, you make a C or a K sound here, as in a tick. Yes, this bit you make this the sound. You pronounce a CK or a K, and then like that, a tick. There we go. As a tick. There we go. And make sure that the final file that you have stored is a is a is less than 1 second in length. So basically it's easy as get a recorder and then tick it and then create a sound on it and then trim it down to less than 1 second by any means, and then and then and then just create some conversions from MP4 to directly to wave, or maybe from MP4 to MP3 and then to wave, and then winsound dot SOD async, so that it can run while not interrupting the other codes, uh, and but this doesn't really matter if this file length is just less than 1 second, so it wouldn't matter. And here, I haven't defined A yet, so it will just pop out a name error. So A equals B, so that this is a current second, so A is a current second, and B is a variable trying to detect a change in the second. Name error, because we haven't defined A yet here. So we are of course just going to get a name error. So int. If there's going to be a name error here, so we are just going to define it here, and then we are about to oh no, we had an error here, and so something happened. Ah yes, 6 to 8. I forgot about that. And then we have completed the clock in 84 lines. No, and there we go. We have a clock that's actually ticking. Impressive, isn't it? In less than 90 lines. Quite impressive, eh? Please subscribe, please like, and hit the notification bell, and also share it with your friends so that everyone else can see this wonderful creation. I know it's a bit flashy in here, but it doesn't matter. And I'm done for today. Goodbye.